Drone. When you guys hear that word, most of you think of a super high-tech, unmanned, futuristic-looking plane loaded with missiles and cameras, right? However, a drone, by definition, is any unmanned aerial vehicle. It doesn't have to be piloted in any way, it just has to be unmanned. They have evolved to be much more of service than just militarily, and are now so readily accessible that any civilian could buy the materials needed to build his or her drone. As you can see right here, it's called an octocopter, and this was built by a person, not the military in any way. Planes can also be considered drones, and as you can see here, like I have, is called a quadrotor, and it is also considered a drone. These machines can be utilized for anything from aerial photography and videography to mapping of farmland to find areas of low yield or dry patches, or even aiding in the finding of lost livestock. This breakthrough in technology has paved the way for future practices of farming as well as many other industries. With so many technological advancements in the 21st century, things are becoming possible that would be considered silly or stupid 30 years ago. An example of this is GPS. With this system, vehicles can be directed or controlled via computer systems. GPS.gov states that tractors and combines were the first to implement GPS into agriculture, called auto-steer tractors and combines. But with this new technology, advancements in aerial drone, remote-operated vehicles, GPS can be implemented into these aircraft to be controlled autonomously and programmed to fly to specified waypoints and return home safely. You can see here, this is a GPS unit commonly used on multi-rotors. Infrared imaging cameras can also be used on these aircraft to monitor crop yield and water tables. These cameras can be built into the aircraft and send images back to the computer controlling the UAV or unmanned aerial vehicle. And as you can see here, this is an infrared image of cropland. You can see where the wet areas, where the dry areas are, and where it may or may not need specific chemical application. Now, video transmission has actually been around for quite some time, really since the invention of the television, but that technology hasn't been implemented into these yet. It's also being implemented into these now. Video transmitters and receivers can be set up in drones to pre-program and send live and wireless video feedback to a receiver and then transferred to a monitor to see exactly what the camera is seeing in real time. This poses numerous threats to personal security, but it also helps get a better image of cropland and enables the pilot to operate from great distances much farther than his or her line of sight. Current applications in agriculture. If one were to take all of these technologies and bundle them together into one super advanced package, you'd get an aerial vehicle capable of flying at distances farther than the eye can see, an auto flight characteristic, and an automatic return to home function, an ability to monitor altitude, air pressure, and temperature, as well as record HD video and report back to the ground station. Current technologies being implemented in the field of drone operation include mapping of cropland to find areas of low moisture, and you can also find specific chemical application. They can also create maps with the pre-programmed waypoints where the drone automatically flies with the GPS unit. These maps can be used to precisely apply fertilizers and eliminate wasted chemicals, as well as reduce environmental damages. They're also used for inspection of buildings where it may be unsafe for people to physically climb and observe what is being inspected. This will prevent many injuries and save lives in the long run. And as stated before, infrared imaging can be used to find areas of low yield where the crops are stressed due to excess heat. This technology can be used in combination with the mapping and photography to create a specific application plan for the chemicals and water to the land. Now, if these technologies keep advancing as fast as they currently are, these drones can evolve from solely mapping the areas that need chemical to actually applying the chemical themselves. Irrigation can be greatly benefited if these vehicles can become strong enough to carry a large payload of water to custom irrigate crops as well. They have the technology to actually plant crops as well as nourish them throughout their life cycle if we can get the payload function currently running. You can see in this picture right here that this guy actually lifted himself off the ground, so the technology is not far off. Progressive Farmer magazine says that the U.S. is a long way from widespread commercial use of UAVs, and anything could happen with them in the future lies in the hands of the public interest and industry needs. You can see the technology to make these quadrotors tiny is very, very prevalent. This one is as small as my hand, but they can also make them as big as the one you see here, and that technology is very scary to many people. But with this new technology, in only the infancy of its development, we will have to come together. We have no idea where it'll be in 20 or 30 years, but we'll have to come together to make a decision very soon if and how it will become the next major advancement that sends agriculture into the 21st century. Thank you.